In this example, we're going to use the slide and divide method to factor this perfect square trinomial. The first step is that we're going to multiply a times c, and that will give us x squared minus 40x plus 400. Then we're going to factor as usual. So we'll make a chart and we'll say what multiplies to 400 that adds to negative 40. And it's a good idea to make a chart listing all the things that multiply to 400. Since it's negative 40 that they have to add to, we're going to have everything equaling a negative number, because a negative plus a negative is a negative, and a negative times a negative is a positive. And so negative 20 and negative 20 are the ones that we're going to use that multiply to 400 and add to negative 40. So we'll write out our factors. The third step is that we're going to divide by a. Remember, a is the number that was in front of the x squared term. And so we're going to divide by 25 for both of those terms. Now we're going to simplify that. Negative 20 over 25, you can use math enter to simplify that. And you get negative 4/5. The last step is that you're going to slide the denominator out to the front. So the 5 slides out to the front, and you'll get 5x minus 4 times 5x minus 4. In this case, the terms are the same, and so we'll write it as 5x minus 4 squared. This is not the only way to factor this. With this particular example, there's actually two other ways you can factor this. One is using square roots, and the other is factoring by grouping. I'm going to show you the same example, just using the fact that they're perfect squares. So, if you look at this problem and you see a pattern, you can look at it with perfect squares. And if you notice that the first term and the last term are perfect squares, then you can take a look at the middle term, and that's going to tell you the sign that you'll need. So this is how it works. This negative tells you the sign inside the parentheses is going to be negative. Then you take the square root of 25, and you get 5, and you put that in front. And the square root of x squared is x, and so you put that in front. And then the second one, you take the square root of 16, and you put that second. So this is a quick way to factor this problem if you see the pattern of the difference of squares. The difference of squares would look very similar if you had the same scenario but you did not have a middle term and you had to subtract at the end. That's called the difference of squares, and we'll talk about that in our next video.